This question's on the topic of combining functions and finding the domains of the combined functions. We're given two functions. The first one is g of x, it equals 1 over the square root of x, and the second is m of x equaling x squared minus 9. There are three questions. We're asked to state the domains of the following functions using interval notation. And the three functions are listed here. Each of them is a combination of the m and g function. So the first question is to find the domain of g of x over m of x. We'll begin to answer that by writing down what g of x over m of x equals, substituting in the formula for g of x and the formula for m of x to get this expression. Recall that the domain is the set of all possible input values. In this case, the input variable is x, so we're looking for all possible values of x that make sense in this expression. Notice that the first place we encounter the x is with the square root of x, which is in the denominator of the fraction 1 over the square root of x. Since x is under the radical sign of a square root, it has to have only positive values or 0. But since it's in a denominator of this fraction, it cannot equal 0. So that value x can only be greater than 0 to be in the square root of x in a denominator. There may be other restrictions on x, though, having to do with the other expression, the x squared minus 9. Now, x squared minus 9 doesn't have any restrictions on x. Any number could be squared and have 9 subtracted. However, that x squared minus 9 is in the denominator of the whole expression. So the x squared minus 9 has to not equal 0. We'll now figure out what x would make x squared minus 9 equal 0. Well, it would equal 0 if x squared equaled 9. So we cannot have x squared equaling 9. And then think through what those x's are. To get x squared to be 9, x could have been 3 or negative 3. So x is not allowed to be 3 or negative 3 in our domain. Putting together that x has to be greater than 0, but it cannot be 3 or negative 3, we conclude that the domain is the interval from 0 to 3, not including either 1, that's why I use the round parentheses, in union with all the numbers beyond 3 to the end of the number line. So from 0, 3, union, 3, infinity. The second question asked here was to find the domain of the combined function g of m of x. That's the composition of g composed with m. We'll first write down what that expression would be. The inner function is m of x, and m of x equaled x squared minus 9. So g of m of x is g of x squared minus 9. Now we put x squared minus 9 as input into the function g. That gives 1 over the square root of x squared minus 9. The restrictions on domain will be that the x squared minus 9 has to be greater than or equal to 0 because it's a radicand under the radical sign. But in addition, this expression's in the denominator, so it may not equal 0. Therefore, we have that x squared minus 9 has to be greater than 0. There are several ways of figuring out what x's would give that. This is one way. We know that the x squared would have to be greater than 9. Now think about that. For positive numbers, what could you square to get a number bigger than 9? That would be x's that are greater than 3. Among the negative numbers, the numbers you could square to get an answer that ended up being greater than positive 9 would be if x was less than negative 3. So those are the x's that are allowed in this domain. Written in interval notation, we have the domain is the interval from negative infinity, comma, negative 3, not including the negative 3, unioned with the numbers from 3 to infinity. The final question on this problem was to find the domain of the function m of g of x. The g of x and m of x have been written here at the top again. The composition function m of g of x equals the m evaluated at the inner function, which is g of x 1 over square root of x. Then we put that as input into the m function and get this expression, 1 over the square root of x, quantity squared, minus 9. That does simplify to 1 over x, minus 9. However, you have to be careful here because in figuring out the domain of this composition function, the x first was put into the square root expression. and whatever x ends up being in as an input to this function has to have a value that was allowed to go under that square root expression. And in addition, that square root is in a denominator. Therefore, the only x's that were allowed to be put into it were x's that were greater than 0. After that, there are no more restrictions on the function, but we do have that restriction. So the domain is the interval from 0 to infinity.